Thank you very much for the introduction and thank you very much for the opportunity to present today. I'm very pleased to do this. Um, so it's my first time attending this meeting as well. So my goal for today is to present some information, but then take some time for questions as well. And I'd be very happy for your questions. So you can interrupt me as we move along, or you can ask questions at the end of this relatively short presentation. And thank you for the introduction. My goal today is really to give a higher level example of a project that we have through NASA that Periato, who is on the call here, it's through his program on using Earth observations and connecting early actions really focused at this subseasonal to seasonal scale, the S2S, and focused on hydrologic disasters. In this case, we're going to really focus on floods. So this first slide is US centric, so I apologize about that. But I think as many of us are acutely aware, there are a growing number of extreme events that are extremely costly. NOAA puts out this map every year. Last year in 2023, there were 28 different extreme events that caused $1 billion or more in damages. So I think this is a product of at least two things. One, extreme events becoming more prevalent, but also having more and more assets exposed that's resulting in these very costly disasters. So we know these occur. They are costly. What I want to focus on today is really the preparedness side of things. Can we better prepare, and what are some tools that we have for better preparing to reduce these costs somewhat? Not to mitigate the disasters themselves, but really to lessen the impacts. Here's a fact that some of you may be familiar with that I really like, that nearly 90% of disaster-related funds target post-disaster response. And while that's needed and while that's necessary, there's also this fact that about every dollar spent in preparedness results in $3 to $6 in savings in response. So there's a clear motivation to shift some of that funding, in my opinion, from response to preparedness. And here's a schematic that I'll use that I think, again, most everyone here will be very familiar with. If we think about a disaster, clearly after that disaster, there needs to be and there will always be a need for response and recovery. In most places, there are fairly well established early warning systems. This is an active area of development. There's not global coverage, of course, but at these hours to days, particularly with some of the tools that many of you here are working on, these are being built out. What we're focusing on in our work a little more is the longer time scale, this months to seasonal time scale, and what Earth observations, what hydrology, what can we extract from the global oceans and atmosphere information to really focus on taking early actions in anticipation of these disasters. And this in no way is meant to come in replacement of these early warning systems. It's really a complementary tool, because I think, as you can imagine, you would take different actions if you believed a flood was likely to occur at 1 month or 3 months in advance than you would at 1 or 3 days in advance. So again, as I mentioned, the idea here is not really focused on mitigating the disaster, the hazard itself, but really better preparation for reducing the humanitarian impacts. So just a few more slides on this. And again, I'm not as familiar with the audience today, so perhaps everyone is acutely aware already of this growing and emerging landscape of anticipatory actions. We've been working a lot with the Red Cross and the START Network and others, and some disaster management agencies within country level governments on these type of plans. And so the idea here, of course, and I'll say it briefly for those that may already be familiar, is there needs to be some type of trigger for actions to be taken. And these triggers usually have two components to them. There's some threshold. This could be stage in a river. It could be 90th percentile of extreme precipitation. It could be sea surface temperatures. It could be El Nino Southern Oscillation Index, whatever the trigger might be. And then we, of course, are predicting that trigger. And using an ensemble approach, then we look at the probability of surpassing that magnitude, or excuse me, that threshold. So perhaps there needs to be a 75% probability of surpassing that threshold, and then actions are taken. And usually these are constructed in a very deterministic or discrete manner like that. So they are clear from an operational perspective. Magnitude, probability of surpassing it. If that happens, actions can be taken. And I've listed a few actions, but there are many, dozens of different actions that might be appropriate, very much dependent on the local conditions and the needs of the local communities. That said, and I won't focus on it too much today, that having these deterministic or discrete values can sometimes be problematic. I mentioned a 75% probability of exceeding. Well, what if it's 70%? Are no actions taken then? So also looking at a gradation of scales could be is very valuable. Then, of course, as I mentioned, there's this financing aspect. How can some of that money be moved perhaps from response to preparedness? What does that look like? What is the appetite for that from funding agencies? And then really, as everyone is acutely aware here, there are a limited number of outcomes, even though this is a complex framework. Either no action is taken or action is taken, and that's the appropriate thing to do. Of course, action can be taken and no disaster happens. And then arguably the worst case is no action or preparedness is taken and a disaster occurs. So there are lots of aspects here from which we can plug in, and lots of opportunities, particularly at the front end of this for utilizing Earth observations. And that's where I will mostly focus. I also have the opportunity to work a lot with social scientists, and they are predominantly the experts, of course, on the downstream side of this. What actions to take, how do we communicate those actions, et cetera. And I'll mention that a little bit more later. So I want to focus a little bit just on these two ideas of prediction and localizing. And I think those two are very related. So I'm going to suggest that predictions can inform local conditions. And I think most of us are very familiar with this. What hazard, how severe will that be? When will it occur, et cetera? And a lot of the tools that we have really focus on this aspect. But I think that we sometimes don't spend as much time trying to understand how local conditions can inform the predictions. What is it that we're really trying to predict? We can predict inundation, for example, and some of the tools that you use. But is that what the community needs? Is that what they're most vulnerable to? How are these predictions communicated? Are the products and the ways that we're communicating these appropriate, or do they need to be tailored in a different way for that community? Just because actions are triggered, it does not mean that people will take action to prepare. So how can these be encouraged? And how can some of these predictions be integrated right into the decision-making strategies? So working on these aspects as well. And of course, the only way to do that is to really work very closely with the communities and to try to co-develop some of these products, which of course is a real challenge, as all of you are, I'm sure, aware, because it takes time, and it means that our products are probably more appropriate, but then it's harder to generalize them for other communities. So again, here making a plug that we need social science. So again, in this anticipatory action framing, here are just for one example of all the triggers that were met by the Red Cross's early action protocols in 2023. It just so happens in 2023 there were a fewer number in Latin America and South America. if you look at 2022 or even some in 2024, there have already been more. So clearly it depends on the year. I want to focus a little bit on just some examples in Peru in two different locations, which look quite a bit different. One is Piura, which is northwest, relatively coastal, small basin, flash flood. So extreme precipitation is really the key hydrologic aspect there. Iquitos, which many of you are probably familiar with, is borders on the Amazon River. So there it's more riverine flooding, and actually more interesting than that is two tributaries to the Amazon pass by either side of Iquitos, and when the Amazon River is high, these tributaries are blocked essentially, and so it's this water that backs up that causes quite a bit of flooding. So there's the physical side, but also, of course, we're interested in the vulnerability side. So the SOVI is the Social Vulnerability Index, and we can use different data sources, census data, other interviews and surveys that have been taken to construct these. But they also can give very different results depending on what we prioritize or how we weight the factors that go into these different types of index. So if we have a general social vulnerability index versus one maybe that's more flood focused, et cetera, we may have very different results or outcomes. So again, looking at the physical and the social aspects of in this case, hazards and floods. So again, the Piura Basin, and just to motivate that there's a high level of interannual variability. Again, this is precipitation that we're looking at in Piura. The Red Cross has an early action plan focused on that. Very much influenced by the El Nino Southern Oscillation. During El Ninos, you can see that northwest Peru is predominantly wet during their rainy season, and so we might associate El Ninos with higher precipitation events. And indeed, that's the case, and those result in some floods. So, of course, two of the dominant El Ninos, 82, 83, 97, 98, resulted in severe impacts in Peru due to flooding. So again, no surprise if we look at a time series, we have in the black solid line is observations. Our prediction model, which I'm not speaking about too much here yet today, are the box plots. And then those are colored by El Nino Southern Oscillation conditions. So red is El Nino and blue is La Nina. And so again, you can certainly see that the two highest precipitation events and streamflow, I guess, were associated with El Nino, but El Nino does not always produce those. And as a matter of fact, La Nina produces some relatively high streamflow events as well that have also contributed to flooding. So it's an interesting question for us is what's happening here, what's going on. And the gray boxes are neutral years, and you can even see that one of the more recent ones, there was quite a bit of flooding in a neutral year, 2017. So if we look at some composite maps of sea surface temperatures, these are all years where there was high precipitation that resulted in flooding. And of course, on the left, 83 and 98, classical El Ninos, 2008, a huge La Nina, and 2017, relatively neutral conditions. So the point is there are other things that are going on. And if you look, I don't know if you can see my cursor or not, but if you look close to northwest Peru, you'll see that in all of these cases, we see some warming SSTs right in the coastal region. And it turns out that these become really important for understanding or for predicting precipitation. And that's mostly in the Niño 1+2 region. So if we look within the season, this is the example from 2008, what we can see February and then March and then April is the evolution of these warming SSTs proximal to the coast of Ecuador and Peru, that seems to really lead to this intense precipitation events. So this is more of a challenge in that from a prediction perspective, we cannot simply look at the conditions of ENSO, Nino 3.4, or even Nino 1+2 at a longer lead in January or even December or November previously. It's really this evolution. And so we've been looking at some of the different models, some of the different NASA or other S2S and sub-X predictions from the general circulation models, the GCMs, to try to see how well they are able to capture this evolution in SSTs and therefore be able to better capture what we're saying is, would result in higher precipitation events. So again, I'm not speaking a lot to the prediction models themselves. Our models are statistically based. We use different machine learning techniques that include aspects of sea surface temperature, atmospheric variables as well, and local hydrology. We also use other observations like GRACE data sets to try to understand the soil moisture conditions, all at 1, 3, and maybe 6-month lead times. Similarly, we looked at the Marañón River, which is a tributary to the Amazon River. And here the condition is almost reversed, where again, same color scheme, but the La Niñas in blue tend to result in higher precipitation events, and the El Niños tend to result in, lower stream flow events. Of interest, of course, many of you are probably following this. There is a strong prediction for La Niña conditions through 2024 and into 2025. And so in the case of the Marañón River, and I would argue probably the Amazon as well, we would be expecting higher than average sea surface temperatures, or excuse me, higher than average stream flow conditions. So our goal really in these has been to focus again on the aspects of prediction, looking at different triggers, the triggers that exist, but alternative triggers, how well can we predict those at longer lead times? And then the downstream effects, of course, are somewhat shown in this figure here, where those triggers then lead to early actions. But there's of course a whole body of research and understanding on how well those triggers, how well those actions are associated with the disaster preparedness, their effectiveness, et cetera, et cetera. And that effectiveness is more challenging to evaluate than some of our predictions. Predictions we're fortunate where we can see if the event happened or not, and to what extreme. If an action is taken, it's much more challenging, as you know, to really understand the benefit of that action, because whether there's a disaster or not, there's likely some benefit to taking actions. I just want to spend a few more minutes and highlight some outcomes from a survey that we conducted in Peru along with my social science colleagues, focused on Iquitos, but interviewing decision makers at both the national level and at the local level here, meaning the region within Iquitos, and trying to better understand the perceptions of flood-related risk, vulnerability, and preparedness. So again, just a couple highlights from that. In terms of state of preparedness, we asked, how would you rate the following areas of natural disaster preparedness? So interestingly, the collaboration among national level organizations and the communication of those organizations seem to be a little bit better or more acceptable, whereas communications with the local communities and the timing of some of those interventions and access to funding seem to be less acceptable. So perhaps some disconnects between national and local level organizations. In terms of risk communication, how effective is this communication? Again, slightly better, slightly more effective at the national scales, perhaps, than at some of the local scales. So we see some themes being highlighted here. In terms of preparedness, this one was interesting to us. There is an agreement that longer lead times could improve preparedness, but then there's less agreement on the ability to communicate those longer lead forecasts. So again, highlighting that there's agreements that they're important, but how they are communicated or how well they can be communicated is seen as more of a challenge. So there's a space that we can all work in for sure. And then finally, just looking at physical and social vulnerability, to what extent they are considered, both of them considered somewhat, maybe no surprise, physical vulnerability still a little bit more. So with that, I do want to stop, and I'm very happy to take some questions. I did not provide too many detailed aspects here, so happy to talk more about those details and happy to talk a little bit more about some of the specific Earth observation tools that we're using. And then again, I want to say thanks to NASA for the funding of this work. So this project we're in the middle of this project now and continuing on with it for at least another year. So I'm going to stop sharing, but I can certainly show some more slides. Again, if that's helpful, but just so maybe I can see any questions. I'm not necessarily seeing any questions in the chat. So I guess I'll just open it up then, that if there are questions, please feel free to unmute yourself or ask in the chat, and I'll do my best to answer those. If there are no questions, it means I explained everything very well, or I did a really poor job and no one cares. So we'll see which extreme we are at.
Okay, so thank you very much for your presentation. I have for sure a few questions, but I will give first possibility to our participants to ask questions. So feel free to raise your hand or just directly speak up. Maybe then I will start. So you already mentioned that you are happy to say more about the Earth observation product. So I would like to ask if you can elaborate a little bit more what exactly you include. You mentioned GRACE, but any other soil moisture products, for example, that you include in your forecasting would be great to hear. Thank you.
That's a very good question. Thank you, and I'm happy to take suggestions from those in the audience here. Mostly we've looked at GRACE and some of the other SMAP products. So that's mostly what we've done from the soil moisture perspective. There is only so much information in soil moisture just due to the seasonality. It's relatively dry, right up to the point where we are issuing our predictions. So those antecedent soil moisture conditions, while informative, do not provide lots of skill in our forecasts. So I'm working with colleagues at Johns Hopkins University, and they're focusing on using GEOS S2S and other S2S scale models, downscaling that information for precipitation, but then they're also running it through some of their products and NASA products, HiMAP and others, so that we're getting essentially streamflow or runoff at a relatively high resolution. We are still in the evaluation perspective of how well those products do for stream flow. So comparing those stream flow predictions with our predictions, and then of course with observations. We've done a little bit more in terms of the precipitation, and those models provide some skill for sure. We've also been pairing them with our, again, models that we've been building on our side, the machine learning models, using simple techniques like random forest neural networks, but other techniques as well, where we're predicting very specific things, precipitation in Piura region, and stream flow in Iquitos or in the Marañón, et cetera. So those models are focused on really just predicting one aspect. And then of course there are other models, Global Flood Awareness System and other models, that we are also evaluating. So ideally, we'd like to put all of these together into a multi-model system and compare across the models, but then look at best techniques for putting those together.
Yeah, great. It would be great to hear more about the results of the comparison. Yeah, it's highly interesting, I think, for all participating today and all the regions. Good, but I see already some hands raised. So Alvaro, maybe I will give over to you for moderating.
Okay.
Thank you.
So please, Jorge, take the word.
Thank you, Alvaro. My question is, the objective of this group of work is to strengthen capabilities, give training to prevent these impacts in flows and hydrometeorological impacts in the whole region. But in case of emergencies, what is the way that we have to do, the way of the authorities have to do to attack directly the problem when the threat is very close? There is a specific group of work, a specific platform, as we do with the group of NASA Servir a few years ago with the ETA and IOTA, who give a immediately response, or in the other cases like the Copernicus emergency system, when those services activate, a group of experts work directly 24 hours a day to give inputs and information to the main decision makers.
That's a very good question. Thank you, Jorge. And I just want to remind you so that we're working at longer timescales, right? So there are these shorter timescale products and systems, as you've said, set up. And those are very important and need to continue to be in place. We are working with Servier also on this project. So for what we're focused on here is really working with Red Cross and with another organization, the START Network, and they have established early action protocols. So they have these protocols that exist, and so even in the absence of our work, these are happening and can be triggered, etc. We're working with them to see if there are ways that we can improve the prediction of those existing triggers in their early action protocols, and also evaluating other triggers that may be informative. So for us, and one of the goals of this project would be pointing the Red Cross to these different products that are available, whether they are ones that we developed or existing ones, so that they have a suite of forecasts that they can be looking at. We can put some multi-model combinations together, make those available. And so again, I do not want to say that what we will produce will be the best, but it will be another source of information that Red Cross and others, or disaster management agencies that sit within government, et cetera, that they can use objectively or subjectively in their decision-making strategy. So maybe that is not so satisfying. I understand that, but again, can we provide information that they can consult? And I agree, training, capacity building, all very important. The Red Cross, of course, so we're working with their climate center. So they're already very familiar with the way that these systems work. They're developing them. So we want to contribute to those that exist as opposed to create something that's new.
Okay, thank you, Paul. Natalia, have the word.
Thank you so much, Paul, for your presentation. Actually, I was kind of curious about to know more about your work, because there are many projects funded by NASA, and they are working in many places in the Americas. So coincidentally, you are working in Peru. So I was kind of curious about, and you already replied to the answer that I was kind of to address about the way how you like the strategy regarding like stakeholders engagement, right? So kind of you point of operational activities is under the Red Cross, right? So I don't know if kind of what is the strategy that you have, if there is another way that you are planning to communicate outside of the Red Cross network, and kind of also thinking from the capacity building program, because Servir has a couple of activities also happening in Peru regarding with another activities, for example, the GeoGlows technology as well are operating in Peru. So kind of figure out the map, right, to see what are the connections that we have in common and that we are not aware yet. So thank you if you can provide some
Thank you very
about
much, Natalia, and very happy to talk about that some more, after the call today too. I will not ever say that we have a perfect understanding of the landscape, because there are lots of projects and lots of tools, and this is just helpful for me to be here today to learn more about those. Maybe to more specifically answer your question, we're also working with Tsunami, the hydrological meteorological organization within Peru, and colleagues there, because ideally so they produce forecasts also. I should mention that we're using or looking at their forecasts as well. Of course, the ideal situation is for us to just either have them own this and use this in some combination with what they're already using, etc. That's not just as easy as them saying, "Okay, we'll take it and make it available." But we are certainly continuing to talk with colleagues at Tsunami. They're interested, of course, not in just the two regions that we're talking about, but countrywide. And so we use some of Tsunami's products also in our evaluation. But yeah, again, happy to talk some more with you, Natalia, so I can learn more about what's happening in Peru and other places.
Thank you so much.
Thank you, Natalia. I let my place to Rodney. Please, Rodney, go ahead.
Thank you. Good morning, all. Thank you very much for the invitation. I'm Rodney Martinez, WMO representative for North America, Central America, and the Caribbean. Paul, thank you very much for the presentation. It's very useful information to know what you're doing in Peru. And my main message here is that as WMO, we will be very pleased to contribute in connecting the dots between the different initiatives. One of the challenges that we have in the region is the fragmentation of efforts. And in terms of preparedness response with the governments, we need to help, to assist, and to have a clear map of what is happening. So we're working with NASA Disasters Program, promoting what NASA is producing, also with Copernicus, with the different space agencies, with GEO. But the idea is to really help as a channel to connect the Med Services community, but also the governments. And I think we will be very pleased to help on the dissemination. And I suggest to do it through webinars we can organize together. But the idea is, if we can show these efforts, these implementations, it's not just for the Red Cross, it's for the community working in the common ground. I think we will be helping to a significant contribution to maximize the efforts to save lives and have better preparedness. So that is my main message, my suggestion, and thank you very much for sharing all of these initiatives. Thank you.
Yeah, thank you, Rodney. And you raise a very good point that we need to remember about being connected and how we can best transfer some of these or make it available to others. I will take your help on that for sure. We are trying to work with other organizations. Some of you may be familiar with ANDEX through the World Climate Research Program, and so working through ANDEX now, where we have a little bit of a broader representation than just Peru for sure as well. So I agree, there are communities that are either continental, etc., that we're trying to work with as well. But anytime we can amplify this, we'd be happy to do that.
Okay. I think we lost Rodney. Yes. Okay, thank you. Thank you, Rodney. Thank you, Paul. And I have a question for you, Paul. First of all, congrats for your excellent presentation. It was very clear. And my question is about, in your opinion, Paul, how could scientists or technique change or impulse politician decision to invest before the emergency moment, taking in account that the priority to do it is very low, because it's a real problem in South America. How is the key action to get success, taking account your experience in Peru?
Yeah, so it's a good question. Probably another full presentation to really try to answer that question, right? And so, yeah, how do you effectively work with communities? How do you effectively work with national and local level decision makers to encourage taking action? We know that politics and political cycles are important, right? And so many factors weigh into this. And so, making some funding available to take those actions is controversial, but it's critically important. And so I'm also very interested in different economic instruments to allow this to happen. So for example, I believe there's a role for index insurance or parametric insurance. Some of you might be familiar with, where very much like the triggers that we've been talking about and surpassing those, if we have a prediction that we will surpass those, can that trigger funding? And so this would require, of course, having skillful forecasts and having an insurance agency or a reinsurance company be willing to write an insurance product based on that forecast, which I understand is, right, the uncertainty can be large there. But I think we need to move towards some of these, because there's really, and unfortunately, as most of us know, a lot of this is just about financing and economics. And it's clear that after a disaster, money needs to be allocated towards relief. And sometimes larger corporations or companies can donate money, and that's wonderful, and they should, and they get some public relations. If those same companies gave some money in preparedness, maybe they don't get the same kind of benefit, right? So it's very complicated how we do this. So maybe there are some different economic instruments or tools that one could adopt to help with the financing piece of it and the preparedness piece, because otherwise, as you say, the motivation to take action can be quite low.
Yes. Yes. Thank you, Paul. Good point of view.
Yeah. Well, and thank you very much for the opportunity to speak. I really appreciate it today.